How's it going, everyone? Welcome. Lear Gonzalez again, looking right now at this recap, especially when we are setting up our build systems and understand what are the things needed, especially when you are defining certain policies to make the CI and CD process, this continuous integration, continuous delivery. And if you are the owner of that repo or that process, there are certain rules that company apply or certain policies that company applies for its security. So today we're gonna make a quick recap of this particular system. We're not going to get into the weeds, and we are going to have now a more practical approach when we need to now is defining our let's going to start with from the beginning, is that understand what maintainable code is, and then what are the things that allows to make this code maintainable. What are the systems that we need to have to put in place, such as the testing, the build system, as well as the static analysis. So once we lay out the infrastructure needed, we can now talk about is how we're gonna set up our process. And those process now then involve is not only how we're going to make this code maintainable in terms of looking at code reviews or looking at blueprints. What are the process of how can we going to add features or change or modify, and what is the document design that we need to as a way to understand this. So and then the infrastructure needed. Again, the idea of this of today's video is that we're going to look now at all of this stuff, all right, and then the build stat and brand protections, some of the security policies that companies are following. So for example, like castle and moat, and now why that is ditched in favor of using the zero trust policy. So anytime you're gonna work for a decent sized company, they follow these particular rules. And then how you can now run multiple jobs, what jobs is, how you can catch independency and catch a configuration. That is the whole point of today's video. So to make this quick, all right, first we look at what is the maintainable, what makes code maintainable, and what are the things that we're gonna look in today's video as a way of how you can make that happen, especially over a long period of time with a wide range of contributors in large teams. And that is, understand that maintainable code is that you have the ability to not only add but change code without the fear of breaking something, update dependency, or migrate, all right? And if you can do that, so your code is now maintainable. So how can we now solve that particular problems? Well, by following is this architecture components or component of a architectured UI, all right, that you need to have is the build system in place, that you need to have the testing infrastructure, the build infrastructure, as well as the static analysis, all right? So once you lay out that, you also need to have your logic, your UI and your business logic separate, as well as some process of how you're going to now provide this maintainability, which is code review, something that I mentioned before, code review, blueprints of how you're going to design some UI elements, and how you're going to change that, and how you're going to bump up versions, as well as how you're going to document some of these design, which is very, very important, especially for the solutions that you're providing. right? And then, well, what is the patterns that you're gonna use to solve this? So, for example, what is the architecture that you're gonna use for these recurring problems? The architecture, the abstractions, how you're gonna split all of these areas, all of this code, into make much more meaningful. How you're gonna manage the state management. So we'd all start with unit testing. Again, part of the basic here. The spectrum of unit testing, integration, component, and then N2E. Some of the jargon used here, like assertion, tests, and test suites. And what are the things that we're gonna use and the tools like React, VTest, testing library, as well as Playwright, all right, and TypeScript. So we also look at when you want to write your test, what are you actually doing that, this unit test. So what are the common or the greatest hits when using this functionality? So we're using now Vite because it's something that is using behind the scene ES build, which is reading in Go, which make hot mode reload and fast build. It makes hot mode reload and fast build. It also is compatible with ESM models. It simplified the migration of your test to this new code bases, which is something that you want to do that. You can handle in its browser-like environments. So for example, Playwright, something that we're gonna see later, improve the error reporting and also provides a flexible configuration. So we also look at what are the concept that we need when we write our tests. Okay, and that is referential equality and referential equality and value equality. What does it mean, and how can we use that in our when writing our tests? What are the methods that allow us to do that? To equal. So we also look at again the greatest hits of that, which is the to be close to for floating points, the to be instance of, pretty self-descriptive, to contain if these elements are now in this collection of values, to throw, useful for a function that wants to check that when something went wrong, you want to throw an error, to match for string, to match object, expect any to check the type, not the value, all right, as well as the array object, the expect array containing and the expect object containing. What you want to check is at least one of these subset of properties now are on this object, for example. Something that is very, very useful. We also look at how can we do that, and now that we define those concepts, we also look is at the way of writing that, the process of writing your unit test. So first start with your setup, then your testing logic, and then with the assertion. Only one assertion. Some recommendations: put everything at a glance, because everybody don't want to actually spend time to look at where is this test is going on and that kind of thing and so on and so forth. No one have the time for that. Actually, no one enjoys writing tests or tests that you have to or writing tests for your own tests. Not a good idea. And some of the advanced techniques when it comes to now handling async operation, because so far we have dealing is with sync operations. And when it comes to handle async operation, what is the technique for doing that? Such as using the async and away, or using is the expect.resolve or reject, useful for promise when you want to check something went wrong. or when you want to check if a particular UI element is not appear and then disappear over a period of time, or when you want to check for date, which is something that actually changed, and what are the things that you can do, especially to fix that. So this is just to describe is the unit testing, the terminology, the concepts, as well as the process of how you can write that, and some common use cases. All right. So this particular pattern, as you can see, is something that we're going to see. We're going to look when we're writing our the build system, right? Using the GitHub action. Again, in this case, we're using is now this concept, which is the continuous integration, continuous delivery, which now the whole point of this is to automate the integration of code and delivery. So the thing here is that with this CI/CD process, again, this is for defining build systems that for automated repetitive monotonous tasks, like anytime you integrate code, you check that works as expected, you build that, you test that, and then you deploy that, right? So this is part of, this is more a complete architecture of this workflow or this process, okay? So hey, you're going to plan what you're gonna do, and then you actually do the implementation, the code, and then that code, once you integrate that, it needs to pass through the CI, which is, hey, let me check if when I build this and test that, it won't break the applications, and then generate an artifact that you can be deployed on another environment, or in a testing environment, or in a staging environment. So for that, which now belongs to the continuous delivery, is like, hey, now that we run all of the necessary tests in this environment, in the staging environments, all right, now which are close to production, is like what we need to do, especially to so if everything went well, all right, in this staging environment, by running all of these particular tests and testing with close to production data, if everything went well, all right, we can deploy not only to production. That's not the end of the story, because we need to actually see if that actually works as expected, operate on that, let the user get feedback from that, and monitoring your app. And that's what you're gonna do all the time here, okay? So how can we now build this particular process? In our case, we're gonna use GitHub Action, which is something that is provided for us, okay? In GitHub Action, the main common use case that you use is workflow, and I think this is something important to know, because once you are giving a particular process, and you give all of these concepts and terminology and blah 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 blah. Okay, the end goal is, what are the things that this is? What are the problem that this particular process solve? All right, because it's very specific, and when you need to apply that, right, it becomes at a certain point some sort of monotonous task. But the whole point of this is to understand where this comes from, and what is the problem it solves, what is the main use case. If you go outside of this use case, you can choose your own adventures, which is a great thing, all right, no problem. But for this course, for this video, we're gonna stick to this use cases, which is also provided not only from GitHub, but from but from not only for GitHub, but for Steve Kinney, this software engineer that has previously worked or that is currently work at Tempora, this open source environment orchestration, which is something that now companies like Netflix, Reddit is using behind the scenes. Environment orchestration, that's quite interesting. That's a very interesting problem. In any case, so the main use case here is that if you have a SaaS and an open source, and for some reason you want to bump up the npm versions of your open source code via PR, you will automatically trigger a workflow to do that on the cloud. That's one of the benefits of this. The other is that it allows us to not only define a process for co-integration, build and test, and when we in deploying our application, every time we set up a release, okay, or a release is created. And the other is that putting a label anytime a issue is created. So this is just to describe what is the most four common use case, okay? And then how can we now, so now that we look at the concept, pretty much like the unit testing, the concepts, right? For example, like preferential equality and value equality. And here we look now at the concept of the build systems, which is continuous integration, continuous delivery, as well as their main use cases. All right. Next question is that how can we write this? All right, using workflows. So GitHub provides this workflow that allows you to now automate the process of running one or more jobs. Right. So you define all of these workflows inside of the GitHub/workflows, so we can reuse those workflows. So these workflows will be triggered by any event, which is a set of activity defined by GitHub, or schedules. You want to actually run this particular job based on a particular schedule, or when you're posting to a REST API. So for example, when you want us to go outside of the GitHub, so you can now activate some sort of webhook in another service. So that's something interesting here. In this event will run now job, which is a series of steps that are that is executed on the same runner. So steps are bash script or actions that is executed one after another in order, okay, and you can have you can share data across these steps because now they are running on the same, they are executing on the same runner, okay. This set of steps can be used actions, and actions are just custom GitHub applications that performs complex but frequently repetitive tasks. So for example, like, hey, let's go to clone the GitHub repo to this server, and you may wonder why to this server, because runner, what it does is GitHub provides you a virtual machines that allow you to run a single job at a time. So this runner, this virtual machine that GitHub provides to you, can just run one single job at a time. This is a new, freshly a virtual machine that can be either Mac or Linux or Windows. But this virtual machine can just only run one single job, right? Or a series of steps, which is bash scripts or actions. And these actions are, well, these complex and frequently repetitive tasks. So for example, like clone the repo into this server, or clone the repo into this server, set up the tool chains for our environment. So for example, in the case of Node, what are the things that you need to have in place to Node works, or Ruby, or Go, all right? In okay. And what is that? Okay. 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 Another example is the setup authentication to your cloud provider. So that's quite interesting here with this GitHub action. It's like setting an authentication with just GitHub providers. An authentication, for example, set on the public API key. So you want to set up an authentication with any of this cloud provider, whether it's Google or AWS. If you're using now to deploy that, this is most the common frequently thing that you can do here. So again, the idea of looking at this and recap this workflow and all of these use cases is because you can get crazy about this. You can create some very wild workflows out there, but the whole point of this is to if you want to keep your sanity, or if you want to now focus on what is the value that this particular workflow provides, if you stick to that, you're gonna get the best ROI from it. And this is most of the time where we want to focus. Again, sometimes we want to actually explore this kind of thing, to say, wow, this is quite fantastic, and hey, you can choose your own adventures. But on the enterprise level, we're gonna choose is more revenue, or right now, especially on pandemics, or when there are a bear market, it's like most of the time people going to look at boring stuff and improve that. All right, because now things that takes too much amount of or innovation is something that requires a lot of time and money. And most of these companies, unless they are the top tech company, not even that, they need the pain of the interest. And now we're entering here in the politics. And if they want to create an oligopoly or a monopoly, they started to play Game of Thrones games. So, but in any case, yes, okay, that's what the reason why I'm focused on this. Good. So I also look at how can I create this. Oh, come on. French toast. Okay. I also look at this. How can we create this particularly workflow? All right, looking at the anatomy. So now we actually know what's going on behind the scenes. So this is to create a workflow, all right, for the CI/CD process. And then when it comes to now put at some of this, which will be the next step on the pyramid of Maslow, for example, the process, for example, of securing or putting brand protections, all right. The idea here is that not only be familiar with this, which is this not only belongs to the okay. What? Exactly. This not only belongs, this branching protection doesn't belong explicitly on the build system. Because remember, at the end of the day, all of these systems is just the basic infrastructure, or the infrastructure, the basic installation needed to guarantee operations. And I think on in this definition is how we can get the most. All right, that's what is infrastructure means. And that also why I actually take a look at the etymology of this word, because I want to know where this word coming from, uh, especially from the French in 1887. Is the installations that form the basics for any operations. Again, the basics in the military sense, and in this case, the basics installations here is that you define is a testing system. You define the basic of the build system, all right, as well as the static analysis, all right. And here we're looking is now more like a process. Okay, again, this is now how Steve Keeney actually created this as a way to create this story, so we can so we can so we can make sense of this. So this branch protection can enter here in the process, all right, especially on the blueprints and code review. The anatomy of this branch protection is that on any PR merging, you want to require approvals, all right, and then don't merge anything if it is a broken build or failed test. So this is kind of the most widely common branch protections that you want to put there, because this is something that require admin privilege. Okay, that's one of the reasons why we need to have a word of security. So the IT department back in the old days, they actually talk about is as a way to protect systems is from preventing access. There is a very interesting Marley Moxie Marlin Marlin Mox sorry, Moxie Marlin Spike. All right. There is a very interesting wait, what? Oh, okay. Well, in any case, Moxie Marlin Spike, right? There is a very interesting yep. Anyway, yeah, Moxie Marling Spike. So Moxie Marling Spike, right? So Moxley Marling Spike has a very interesting podcast with Joe Rogan, okay, where he talk about is the security, right? Security, strategy, securities. Da, da, da. I think it's this one. Fair use.
The Joe Rogan Experience.
Fair use.
So fundamentally, there's two ways to think about security. One is like computer security, this idea that we'll somehow make computers secure. We'll put information on the computers, and then we'll prevent other people from accessing those computers. And that is like a losing strategy.
That's right. That's right. So again, he is the creator of Signal. He's also security research, right? So Moxie Marling Spike. Yeah, security research, founder of Signal, and security in software security research, most likely that. Yeah, software security research, and well, with that, all right. Wait, what? Hold fast. Anyway, but yeah, Moxley Marling Spy described briefly is in that podcast. I suggest you to take a look at that, and also I'm gonna leave the link in the description below. Is that security? Is this idea of now we're going to put things on the computer and we're gonna secure that and prevent access to it. This is known as the castle and moat security. So the thing is that this model, according to Cloudflare blog, is like it protects you from other or from external threats. But when those threats cross the moat, you actually is helpless. So it's not effective. So because once they do that, they can not only exploit system vulnerabilities or inject some malwares or steal credentials and do social engineering attacks. So all the security research, all right, which is now why this top tech company has embraced, and why, for example, all of these small companies are just following what they're doing. They are not in the field of innovation, they're just in the field of just clone that, despite that, well, most of the employees are not that talent, or they would need to raise the bar. Okay, that's what I always focus on, that you, whoever are looking at this, you must strive for performance for yourself, as a way to get the outcomes that you need, especially in your health, in your physical health and that kind of thing, mental, physical, and if you can, spiritual. All right, but this research, all right, that they found out that this castle and moat IT security model is not good, and also it's expensive because they're using this VPN, and they are not that scalable, because anytime that they need to add more employees to the company, there is also an increase in managing now new servers and configuring that. But all of these companies now are relying is on other third-party services like Cisco, for example, they are going to be where those companies now focus on this particularly niche, this market, and how from there they are assuming a lot of these customers in Cisco, they're going to provide is exceptional results because data and their business is at stakes. And they also can be there can be a lot of lawsuits and the kind of they want to prevent any kind of that. So the vast majority of this software factory now have put their trust in all of this small set of bigger companies. Cisco is one of them, and then other security companies like that. Where the whole point of this is, do what you need to do to guarantee me this, which is security. So that's why they follow is this zero trust policy, where the idea here is that they're going to assume that no one, externally or internally, is to be trusted by indicating is how and when people are allowed to access, or users are allowed to access to system data. So any time that they want to get access to, they need to prove who they are and where they're coming from. Okay, so that's one of the main idea of the zero trust security model, is that hey, we don't trust in external or internal, and that indicates that how and when users can access to the data, right? So one of the principles, this is something that we are slowly now going and using that, all right, is that, well, those companies now are continuously monitoring and validation. Something that you can even do to yourself is you have kids or pets, you're actually constantly doing that, hey, to continuously monitoring and validate that. The other is the principle of least privilege, which is applicable to this branch protection. Is that hey, this admin user should have is just a small set of rights, and any contributor should have more only the necessary rights to do that. So this is actually following is this practice. The other is device monitoring. So any time a particularly device actually access to one of the system, one of the business asset, digital business assets, it needs to be is so you need to verify, you need to check who you are. Followed by the micro segmentation, so they make now this network small and easy to manage, and the multi-factor authentication, where the idea here is that by using several authentication, by proving that you are who you say you are with different things that allow you to say, hey, this is me, and this is all of the things that I have to check for that. So we have now is the biometrics, the physical access, for example, the two-factor authentication is like by email and by receiving a code in your cell phone and that kind of thing. And the other is preventing lateral movements. Another principle is that, hey, once a user access to a system, by putting is all of this guards in the way how they access to the systems, they can prevent to move there, right? Because all of these systems, so you can think of this as like once you get into the castle, you already know when to move, right? You can move from one place to another in that castle, inside of the castle. But the idea here is that even though that you are getting into the system, or at least in one of those houses, if you want to go to the next one, all right, or the next bar, right, it make it harder to do that. How so? By checking who you are, all right. So the bouncer at that bar say, hey, no, who you are, where are you coming from? It's putting all of these guards here, and if you can provide who you say who you are, it's like no, and then it might raise the alarm. So again, this is a very interesting problem to solve, right? And there's some policy here that they follow. For example, the SOC2, where SOC2 is more for legal compliance, all right? Yeah, where SOC2 is more for legal compliance. Service organization control. Why this is in? What about this? Okay, system organization control. Okay. Is it for auditing that there are trust criteria? It's 18 standards. General accepting auditing standard produced and published by American Institute of Certified Public Accountant. Okay. Okay. Trust service. Okay. It's for trust services. But it says system organization control. System organization control. System organization control. Oh, okay, this is part of the quality controls. QMS. Quality management controls. Okay. The service and organization control too is report based on auditing standard board of the American Institute of Certified Public Accountant. Service organization control. Oh, from the American. Oh, okay. From the American Institute. American Institute Public Accountant. For service organization, trust server criteria. Okay, but this is trust service criteria, and the zero policy trust security is a security model or IT security model. And I think this is something that can apply to other companies as well. Not only that, but like that. Okay. That's interesting. Okay, but so the difference between SOC, you suck. SOC2, which is a service, which is a trust service criteria, is a standard organization control. Existing organization control, and the zero trust policy is that one of them is the security model that this IT company follow, and the other is that how trustworthy these systems are. And this distinction is crucial here, especially when we talk about hidden security. So SOC2 stands for system organization control, which is a trust policy. It's a trust service criteria that say this system is to be trust. So whoever is admin, that whoever is the owner managing that, actually is someone that you can trust. So if for some reason you change the policy, or if you try to be a smart ass with the business assets, that's not only gonna impact badly the reputation of that company, but also yourself. So again, one of the things of image consulting is that we are constantly exchanging our image, and this is our token. This image that we build, we like it or not, which is something intangible, it is. We are constantly is exchanging that, right? And because it's something that is quite ethereal, and some of the things that we can look or we can observe are the appearance is one of them, but some other that are more abstract but valuable are the behavior, how you act when something went wrong, or when something is out of the place, when something's off, the way of how you communicate, all right, how do you deliver the thing that you need to do, and also right now with the digital footprint is that what are the things that you're putting on the internet, and what are the image that you're building there. This is something that we are doing a lot, every day, every single day, and it's not easy. No one say that life is going to be easy, but yet interesting. And I made that, or I bring that out here because especially when you are now talking about security for systems or for yourself, you see yourself as a business, in the context of software, there are several policies that are applying. So for example, SOC1 or SOC2, which is system organization control, which is trust policy or trust service criteria. Hey, is this system actually are doing what it's supposed to do? Can we trust in this system? Not even people on Google actually do that, despite that they are actually using SOC. But I guess that's lobby. And then you have also the security models here, right? Which is the castle mode and security and zero trust security, zero trust policy model. So again, one of them focus on security, the other focus on trust. A word of trust and security. Okay, so with that in place, all right, and also what is the principle of this security stands for, which is, well, continuous monitoring and validation, device monitoring, okay, the least privilege, the principle of least privilege. Micro segmentation is that, hey, we're going to now make this network smaller so we can easily audit, preventing lateral movement. Once you get access to a particular systems, you are going to ask about your credentials, so we're gonna define some mechanism to know who you are and where you're coming from. Okay, and those mechanisms are these multi-factor authentications. So whether it's as a way to identify who you are, you need to provide us is several items or tokens where we can check that who you say who you really are. So whether it's a SMS password, whether it's an SMS or email token, or using a time-based password, or a QB key, hardware identification, that kind of thing. So digital, physical, or any other media, it makes a lot of sense. Okay, cool, bro, cool. Holy moly, that was a huge tangent. Go back here. Okay, all right. Jesus. That was a huge tangent, man.
Again, like sometimes I hate these things. But I would start small and build up, and you can create this. Cool. So now I've got these branch protection rules in place, and now I can't merge a broken build-in.
Okay. So that'll be all for this video. I just want to make this video, even though that at the beginning I talk about is that we're going to focus this on how can we define running the multiple jobs and catching dependency and catch configuration. I want to make these videos exclusively for a word of security, whether it's trust, a word of trust and security, by looking at SOC, all right, this security, this system organization control 2, version 2, as a way to now provide trust to your consumers. Is that, hey, this is a trust service criteria that give us, what I will tell you is like, hey, yeah, our systems are trustworthy. Similar for the security models, all right, castle and moats, the trade-off, as well as zero trust policy. So that'll be all for this video. Take care. Bye-bye.